Hello everyone, welcome back to the Lighting Controls Academy's video series. If you haven't checked out our other videos, I highly recommend you check them out. I'm the Education Manager for the Lighting Controls Academy, Webster Marsh, and today we're going to be talking about daylight responsive lighting control. So let's get into it. So the way that this video is broken down, the first thing that we want to talk about is what exactly is daylight responsive controls and how they work. Then we're going to briefly go into energy code requirements. Then we're going to get into how you specify daylight responsive controls, and finally, how you guide the programming and calibration of these controls devices. So, what is daylight responsive controls? Well, first thing that we need to define is what daylight is, because otherwise we have nothing that we're controlling, or at least responding to. So, when we're talking about daylighting, or daylight, we're talking about the exterior light that's coming in predominantly from the sun, and is reflected potentially off of an exterior surface. So if you don't have a direct line of sight to the sun through your window, but maybe you have a building that the light is going to reflect off of and come into the space, that is also considered daylight, or just the general sky glow of the exterior space. Whatever the natural form of light that has nothing to do with electricity that is coming in during the day, that's essentially what daylight is. And the reason we need to define this is because we need to figure out exactly what it is we're responding to. Interior daylight is typically the result of this exterior daylight coming in through a fenestration, fancy word for opening in the building. Ultimately, some way that light is getting into the building, and it might even reflect off of the surfaces around the space and just fill up the space. When it enters through, typically with most commercial lighting controls projects that you're going to see, it's either going to be through a top light like a skylight or a side light like a window. And ultimately, good daylighting, which is when you're starting to manage the daylight that's coming in, it wants to be diffuse. You don't want that super bright, glary sunlight hitting your face. It's a lot more comfortable when it is managed and controlled and the glare is cut down. So that's one of the first steps of daylighting, is to just manage how that daylight is coming in through that fenestration. So when we're comparing daylight versus direct sunlight, which is what is the heavier glare experience, daylight is what we're utilizing for the task that we're trying to achieve. So if we open up a window, we are using that daylight to illuminate maybe a table or a desk, and the direct sunlight might be a result of using daylight, but hopefully we have, again, managed or diffused that light to be able to make it more comfortable and usable for our purposes. Daylight is best when it's managed through some form of glazing or shading. So you see a lot of times we have, shades, window shades that kind of partially block the sunlight, make sure that it cuts down on the glare. We might even have permanent louvers on the outside of the building, or again, just the glazing, how we've frosted the glass can help cut down that glare significantly. And so when it comes to these sorts of devices like the blinds, you oftentimes have options where you could either manually control the blinds just by pulling a cord, or you could have motorized shades that are either, manually demanded to open and close, or you could have automated daylight management where it is detecting the illumination and then responding, and it can either be with the shades or with the light fixtures themselves. Now, the reason why you might want to do shades rather than lighting, which is what we're going to be talking mostly about, is because you want to be able to cut down as much contribution from the daylight into the space as you can for any number of reasons. Again, if it's direct sunlight and you really need to cut that down, or maybe the space is a presentation space and having daylight is just too bright and too intense and takes over the space and blocks any media walls or TVs, and so really having that ability to cut off the sunlight entirely might be the more preferable way. Now, when we're talking about just daylight responsive controls, which is mostly a lighting control method, we're really talking about measuring how much daylight is being contributed to a space and responding to that amount of contribution. And it could be either the actual direct sunlight or it could just be reflected light in the space. But ultimately, once those sensors detect that daylight, they're then going to adjust the electric lighting's output. And one of the reasons is to reduce energy waste. It's not the only reason, but it is a predominant reason why we see it being used in projects, is because when you have so much sunlight being contributed to a space, you really don't need your fixtures on because they're not really doing anything to contribute to how much light is in the space. And so that's where Energy Code has kind of stepped in as well to say, hey, you probably should have some daylighting going on, or daylight control here, to be able to cut down on that waste. And so we have often seen through the evolution of daylight responsive controls, it used to be that you would just switch the fixtures completely off when you hit a certain threshold or a certain amount of light. And you still see that pretty commonly in exterior lighting controls, especially with street lights, where it just, if it detects daylight, it immediately turns the lights off. And if it detects that there's no daylight, then it brings the lights back on. But there's a lot more fancier ways of controlling lighting than just switching them on and off, and a part of it is dimming the fixtures so that you can maintain a certain level of illuminance in the space. What we're seeing is that it used to be really hard to get people to adopt daylight responsive controls, primarily because of that hard switch on off. Just like any lighting controls, you want to make sure that the changes are smooth and not really noticed. It used to be that when lighting controls would shut off on people, people would notice it. They would think that the fixture is malfunctioning or something's wrong, and they'd, find it very distracting. So we've really tried to identify that and address those concerns, and we found that having a much more smooth transition from brightest state to its target state is a better way of approaching adjusting the lighting in response to the daylight contribution, and in some cases even leaving fixtures at a little glow to make them look like they're still on, which they still are on, but that way people don't get distracted by fixtures shutting off, especially if you have a big troffer that takes up a huge amount of space. If the big troffer stays on at a glow, it'll still appear to be functioning for the space, and people don't have to worry or hover over that fixture. It is a little wasteful, but it's better than having fixtures full on, because the contribution of daylight is significantly more than most electric light fixtures can actually provide. And so it really is a huge waste if the fixture is on at full output. So I mentioned one of the benefits, primary benefit being that we have ongoing energy savings, because again, when we have our light fixtures on at full output and sunlight is, flooding into a space, that really is a waste, because the sunlight that's spilling into an office through an open window is really going to be significantly more powerful than the electric light fixture is. And so when it's at its highest intensity level, when you've got direct sunlight, even if it's modified by louvers to cut down the glare, you still have a huge contribution of light to the space. So really just dialing it down in response to that presence is a great first step to energy savings. But it does depend on the fenestration. So if you have a really heavily glazed window or tinted window, that contribution from the daylight might actually be a little bit less, and so you might not have as good of an energy savings as opposed to if those windows were just completely untreated. But at the same time, going back to that whole conversation about delighting, you might have a really glary experience. And so there's this balancing act between what is best for comfort versus what is best for energy efficiency. But also daylight availability, depending on how far north you are or how far south you are, that could really determine throughout the year how much daylight you are going to get through those windows. And again, how the design is controlled, or the controls are designed for the system, because that will also impact how much savings you have if you are just switching on and off versus if you're dimming and to what degree you're dimming. But there are also other benefits to having daylighting. So comfort as well, being able to occupy the space and feel comfortable with how much light you have. You know, adding electric lighting to daylight might actually make it too bright of an experience in some cases. And so making sure that people are comfortable in the space when there's daylight present. But the other thing is that the less we use our fixtures at a high intensity value versus a low intensity value, if we dim fixtures down a lot, we're actually going to save the lifespan of that, because most fixtures nowadays are LEDs, and LEDs wear down with use, and depending on how much or how intense you use those will determine how quickly the LED loses its capability of emitting light. And so if you keep everything at a lower level, at a dim state, the lifespan of that fixture will last a lot longer than if it was always at full output. And additionally, we want to make sure that things are comfortable and uniform. And so, the lighting designers, if there's a lighting designer involved in the project, is going to make sure that their electric lighting is hitting a target foot candle or lux level on a task surface. And the daylight, a good daylighting controls design is actually going to try to maintain that level under all circumstances when daylight is involved. So having that daylight detection method and daylight responsive method is actually going to work towards the benefit of the lighting design. All right. So energy code is the unfortunate reality of most commercial lighting controls projects. When you're working on a lighting controls system for a commercial building, you are going to be dealing with energy code requirements of one kind or another. So we're going to go a little bit into what kinds of expectations you need to adhere to when it comes to energy code. So energy codes, if you're unfamiliar with reading these, they oftentimes do have some daylight responsive controls requirements, and predominantly for how you zone your daylight responsive controls and your fixtures. The most common ones in the United States are IECC, ASHRAE 90.1, or Title 24, and they each have their own different requirements for what daylight zones are and how electric lighting is responding to daylight's presence. And even each year, so every 3 years, these codes will be updated, and it's up to the states to adopt these codes. So some states are a little bit more relaxed and have an older version of the code, and some states are always up to date on the latest code and have the most strict requirements for energy code compliance. And you need to be able to meet these to get your permit for the project. So being able to show whether you're complying with this is really critical in the design documentation. Now, there's a lot of variance between the different codes and the different years that they've come out in the terminology that they refer to, but the most common terminology that you'll see is basically primary, secondary zones. And so when you see sort of these terms, that's when you're talking about breaking up the fixture controls throughout the project. And general lighting tends to not be part of the daylight zone. It tends to be part of the regular lighting that has no impact on the daylight responsive controls. So most energy codes that are current will require continuous dimming as a way of dimming your fixtures. There are other methods of dimming that we'll get into in a moment, but it's actually best practice nowadays to just expect that your fixtures are going to use continuous dimming, because most fixtures, especially interior fixtures, are going to be by default continuous dim capable. And so to request something other than continuous dimming may actually add cost to the project unexpectedly, because you're using hardware that's less common nowadays. So how do we design to energy code? Well, the very first thing that you want to do is you want to be able to identify how much daylight you're actually going to be working with. If it's a nice big window that's facing to the south and it's in a southern environment, then ultimately you're going to be dealing with a lot of daylight. Whereas if you have a small window on the north side of the building in a northern climate, you probably are not going to be dealing with a whole lot of daylight to begin with. And so being prepared for how much daylight you are going to be interacting with is a really critical first step. The next step is to identify where your daylight zones are going to be. Most of the time, it's going to be your perimeter daylight zones. So wherever you have windows, you're going to identify, all the fixtures that are close to those windows that might need to be controlled. And energy codes have a primary and or a secondary required zone. So the primary zone is what's closest to the windows, and the secondary zone is a little bit further away, but not necessarily the furthest from the windows, because the furthest is not going to get much daylight, if any daylight, to begin with. But the closest ones, they're going to get a ton of daylight contribution, whereas in between is going to be a little bit of a half. So if you're just adjusting the middle zone of lights to the same level that the lights closest to the window are dimming to, you might actually not get enough light in that secondary area. So that's why we break it out into primary and secondary zones, because it gradually over the distance of the space is going to be reduced in its performance and contribution to the space. So that's why we want to identify, how much daylight's coming in, because then we're going to determine how we're zoning based on how much daylight's coming in. And part of that is defined in the codes, and that's usually based on the height, location, transmission, and obstructions. A lot of people just use the height and width measurements, so there are specific requirements. Sometimes it's 1 times the height, sometimes it's 2 times the height, but you take the height of the window, this is for side lit specifically, and you multiply it to see how far into the space you need to zone your daylight zones, your primary and your secondaries. And so again, this is specific to side lit zones. Skylights or top lit zones are going to operate a little bit differently, but they'll still have the same basic understanding of primary, secondary, because again, you're still gradually losing that daylight contribution over a specific distance. And so again, within the energy codes, they are very explicit about how you define your zones and how you identify them, but it's predominantly based on what that fenestration is. All right, so now that we have an idea of energy code requirements, how do we specify the daylight responsive controls themselves? And so the very first thing that we need to ask ourselves regarding daylighting control is whether we're using open loop or closed loop control. Open loop is when we're measuring the daylight itself. We're not measuring anything else, so oftentimes you'll see sensors on the outside of a building or on the top of a fixture, and that way it's not measuring any electric light. It's just measuring the daylight. Closed loop sensors, on the other hand, are going to measure both the daylight and the electric light in the space or on the surface that it's measuring. So closed loop has that ability to drill in and dial into a target illuminance and try to maintain that illuminance by managing the electric lighting in combination with the natural light coming in with daylight. But that will depend on a number of factors, such as your surface reflectance. So if, for instance, you have your sensor aimed at a bright white surface, that might actually show an artificial high level of light, whereas if it's a dark black surface, it might have an artificial low level and boost the electric lighting just because it thinks it needs to compensate for a loss in illuminance, because it's measuring reflected light. It's not actually measuring the light that's contributing in the space. So ultimately, there's not really an ideal choice. How you place your sensors and how you zone the fixtures is really much more important than making the choice of open loop versus closed loop, but it's always a good thing to think about when you're starting to design your lighting controls for daylight responsive controls. So getting a little bit more deep into this. So open loop sensors are really exposed to the daylight. So we want it either mounted to the exterior of the building, on the top of the fixture, near the windows, as far away from any electric light contribution as possible. And in most cases, these sensors are going to be a little bit more forgiving than closed loop sensors. So their ranges, their detector ranges are a little bit more coarse for detecting how much light is striking them. In some cases, they might just be binary. They might say, is there light or is there not light? And then, turn on or turn off the fixtures. But with open loop dimming sensors, it does have the ability to respond to a variable daylight, but it really is best for stable, unshaded situations. So if you don't have like blinds that you're opening and closing all the time, and you have, pretty consistent daylight throughout the day, as opposed to, if you have like a lot of obstructions, a lot of trees or something that could cause, light to come through at certain times, that's not as good. So having just a clear open window and a clear unobstructed view is going to be best for an open loop sensor. And so that's why, again, having them on the outside of the buildings or on the tops of outdoor fixtures is best, but it doesn't measure those task levels. So keeping that in mind, you might need to think through how you're going to override if there's something that's going to happen, like a cloud passing by, and we'll get into that later on with calibration. But it's just there's a fussiness to open loop that closed loop doesn't have, and vice versa. Closed loop also has its own fussiness, which we'll get into. So with the closed loop sensor, we're measuring the total light in the space. That includes the electric light. So let's say, for instance, you have a sensor on the ceiling aimed at a table or a desk. It is going to see how the daylight is contributing, it's going to see how the electric light is contributing to that surface, and it's going to measure the total combined illuminance that is reflecting off of that table. And so it is better when you have those shaded spaces, or when daylight is going to be changing more repeatedly. If you have somebody who goes over and likes to draw their shades or close their blinds frequently, and so your lighting might need to respond a little bit more agile to what's going on around it. And so that's where closed loop sensors are a little bit better. But the challenge of finding the right placement for these sensors can be harder in some cases, especially if you have a sensor on the ceiling and it is above an indirect luminaire, for instance. So having an indirect luminaire aimed at the sensor will actually create an artificial impression that there's a lot of daylight in the space, because it doesn't know the difference between electric and daylight. And so as a result, it might keep the light fixtures at a low level despite the fact that there's no daylight in the space. And so making sure that that sensor is properly placed might be a little bit more challenging than just putting an open loop sensor right near the window. But at the same time, the ability to measure the task surface does outweigh the cons in some cases. Now, that task surface does have to be consistent. So like I said, if you have a white table, but then somebody takes a black tablecloth and puts it on it temporarily, that sensor is going to have an artificial understanding of what's going on, and it might adjust the lighting in a way that's not actually going to be helpful. And so making sure that, okay, this is a desk in an open office and they're just going to be using, white paper is fine. But if it's like a dining hall or something and you don't know if they're going to start using darker tablecloths, all of these considerations are really important when considering to use closed loop sensing. But again, there's a lot of arguments to be made for and against either of these. And again, you might even consider using both, where you have an open loop sensor that is used during specific times of day or under certain circumstances, or even just to measure how much daylight is actually coming through a fenestration, and then having a closed loop sensor that is either a redundant detection method or an additional layer, or again at different times of day for detection purposes. It really varies, but it's not to say that it's an either or all the time, but it will depend on the manufacturer that you're working with and whether or not they can employ both methods together. So just understanding the difference between these two methods is important, and deciding how you're going to be detecting the daylight. Now, once we've determined how we're going to detect the daylight, we can actually get a little bit more into how we're controlling the zones. So when we say zoning, if you're unfamiliar with this term, we're talking about how we're grouping the fixtures and controlling them simultaneously and uniformly. So if we have, a bank of light fixtures that are right next to the window, we might want to control them all together in a single zone. Control zones can, in general, be matched to the daylight zones. So we could have, the primary zone is zone A for the lighting fixtures, and the secondary zone is zone B, and the interior general lighting is zone C. Or we could have even smaller zones nested within these daylight zones. So we could have, the north group of fixtures is zoned as zone A, the south group of fixtures is zone B for the primary zone. And then the secondary zone, we have C and D, and then the interior will have E and F. And so how we zone it really can be up to us so long as we still follow the primary secondary method of daylight zoning, but we can make those as small as we need them to be. And in some cases, you may actually want to make them smaller because, let's say, for instance, you have a really long window that's covering the entire width of the building, and it's a big open office. What happens if somebody shuts the shades on one side of that office, but the other side has the windows wide open? If you only have one sensor, then that sensor is only going to detect the daylight in that specific portion. So having multiple zones within the primary zone might be helpful to avoid either making the lights too dim or the lights too bright, depending on what's happening in other portions of that area. And so primary zones, as I mentioned, because they're closer to the windows, they tend to be more significant in how they dim than the secondary or the interior general lighting zones because of the contribution from that daylight. So it's expected that whatever zones are within the primary daylight zone are going to be dimmed down maybe twice as much than the fixtures that are in the secondary zone. But, sometimes you may even want to get, drill that down even further, especially if, say, for instance, you have a linear fixture that is spanning multiple daylight zones. How you split that may actually determine the aesthetic experience of that fixture. And so while I don't necessarily recommend that you have a linear fixture that spans the entire length of the space and gets cut up that way, it happens, and the way that you address that is going to be how granular do you want that adjustment to look like, because the contribution from that fixture is still going to be dramatically impacted by how much daylight contribution you have, and energy code requires that you still split that fixture up. And there's even more considerations when it comes to control zones with daylight responsive controls. So when we're dealing with it with daylight, there's partitions that can create different daylight conditions, especially if you have really high cubicles, for instance, if your open office has cubicles, or other sorts of reflectances within the space can really adjust how bright that space actually is going to be and how much the daylight is going to contribute to the illuminance of that space. One thing to keep in mind, though, is that you don't want your control zones to be bigger than your daylight zones, because then you're no longer in compliance with the energy code, and additionally it's not going to be effective. So the reason there's a primary and a secondary in most cases nowadays is because of the fact that if you just had one big primary, it would be way too dark towards the tail end of that zone. So making sure that you at least adhere to the primary secondary for your control zones is the first thing that you should consider. The other thing that's worth considering is the difference between analog and digital. So analog wiring, you are fixed to the circuit, and you need to pre-plan how you're going to be zoning the fixtures because it's going to be dependent on how they're wired together. Whereas if all the fixtures are digital in their controls protocols, that does allow you a little bit more flexibility, and you don't have to necessarily predetermine how your daylight zones are going to be breaking up in your control zones. So it's just a worth consideration to think about doing digital versus analog. Not saying that every project it's applicable, but it's always worth considering to think about and ask yourself, is a digital protocol best for my project? All right, so now let's get into how we're programming and calibrating everything. The very first thing that we're going to be thinking about is the sensors themselves, how we are measuring the space. These are our eyes for the system and how the system can know what's going on. So the light sensors will have that input from the daylight. So they'll either detect the presence of light or they'll detect how bright it is, and they can either be mounted on the ceiling, mounted on the wall, they can be right on the mullions for the windows, or they can be even inside the luminaires that with a little sensor that's poking out of it. There's a lot of options for where we can mount these sensors, and they really do vary in size, and they might even be within the wall boxes themselves. If you're unfamiliar with that term, wall box just means everything in one box. And so I've seen really itty bitty light sensors, and I've seen really large light sensors, and it really depends on the technology and the manufacturer that you're working with, but size really doesn't determine a whole lot about that sensor. Most lighting sensors do have similarities between them nowadays. But the most important thing really is how you're placing these sensors and making sure that they are being optimally utilized for their detection method. And a lot of manufacturers will actually have guidelines for where best to mount their sensors. They might even tell you how many feet away from a fenestration you want to have it, if it's ceiling mounted, and if there's any other additional parameters. They're usually very informative about that, but it's always good to double check how these light sensors are being utilized for optimal performance. So getting a little bit deeper into the specs of these sensors, there's a lot of things that are worth paying attention to when it comes to how they function. The very first thing is its range of response, and what I mean by that is how much light it can respond to within a specific range. For example, open loop sensors tend to have high ranges because they're trying to detect between 0-foot candles and 10,000-foot candles, depending on whether the sun is directly in view or behind clouds or just rising or setting. And so it has that large variance, but it tends to be a bit more of a coarse variance, whereas closed loop sensors are really meant for within a specific range of 0 to 75-foot candles, because it's trying to maintain an interior task level illuminance. And so it might be more fine in detection method to being able to see the variances between each foot candle level. But this is one of the first things that you want to make sure that your sensor is capable of aligning with, because if you have if you put a closed loop sensor outside, it's really not going to be optimal for your daylight control. So just double checking that spec, and then also checking the directional sensitivity. Now, a lot of interior network lighting controls don't have a huge amount of variance between their directional sensitivity, but it's something to keep in mind, which is to see how the sensor responds to its view angle. And so the housing and lens will modulate how much light is being contributed from each angle. And so a wide angled lens is going to be able to see, really in lots of different directions, and so it's more geared towards open loop detection, because it's just trying to see, okay, on the horizon is the sun up or not, and so it will get impacted by adjacent illumination sources. Like if it's mounted right next to a light fixture, it might see that light fixture, and so mounting that device as far away from any contributions is going to be helpful to making sure that it's most effective. Whereas narrow response, narrow view really drills into a very specific area. And so this is best for closed loop where you have it on the ceiling and it's mounted at a desk. And that way it's trying to kind of block off any adjacent light sources, like for instance an adjacent light fixture that might contribute to an artificial detection of light. So the next thing that you want to look at is set points and deadband. Interesting terms. Let's go into what they mean. So set points are the threshold for which something is going to happen. So let's use an outdoor open loop photo sensor that is just turning lights on and off. It has no dimming control. It is going to be set to 5-foot candles because it's just trying to detect whether there's daylight out or there's no daylight out, and 5-foot candles has been the determined level that makes sense. So if the lights are on and the sensor then suddenly detects above 5-foot candles, it will shut the lights off. If the lights are off and the sensor suddenly detects less than 5-foot candles, it will turn the lights on. However, we also have deadband, which is how broad of a variance are we talking past 5-foot candles before it will actually trigger. So instead of directly on 5-foot candles, because let's say for instance the amount of light is not consistent for some reason, might be because of a tree that's blowing in the wind or something, that way the lighting is not just going to flicker on and off because of how variable that light quality is. So we might say between 3 and 7-foot candles instead of just right at 5-foot candles. And that's the deadband, 3 to 7-foot candles, which means that just don't react until it passes the deadband. So we might be targeting 5-foot candles as our set point, but really it's between 3 and 7-foot candles that you're going to not react, and then once you pass that threshold, you're going to react. The thing is with set points, it's interesting because it kind of flips your perception and what you normally think of when it comes to set points. Because normally when we say a high set point, we're talking about the lights are going to be really bright, and a low set point, the lights are going to be really dim. But it's actually, we're talking about what the sensor's seeing. So a high set point is actually going to result in dimmer lights, and a low set point is going to result in brighter lights, because what we're trying to do is compensate for either one. So if there's a lot of light coming in, that's a high set point, whereas if there's very little light coming in, that's a low set point. And so we just want to be able to compensate, and it takes a second for you to just recalibrate your own perception of what this means when it comes to daylighting. And tuning the deadband really is more about stability and comfort level. So getting a sense of, okay, if it's a very small amount of light, you might not need a really broad deadband, but if it's, depending on the application and how variable that light is, you might get a sense of, by standing in the space, just to understand, there's a lot of cars passing by and they keep, flicking light up at the sensor. But deadband is not the only way to prevent unsavory results from your lighting. There's also ramp rates and time delays. So ramp rate is going to be how quickly that change happens. So going back to our outdoor sensor, we're now going to give it dimming capability. And so when the light decreases past 3-foot candles, past our deadband, the change in the brightness of the fixture from off to full could happen instantly, like an on-off switch, or it could happen very slowly. And when it happens very slowly, that's a very slow ramp rate. And slow ramp rates are much less noticeable than really fast ramp rates. So we would like slow ramp rates for daylight control, especially with dimming, because of the fact that we really can help make it an imperceptible change and allow for people to be more comfortable with the lighting that's being provided. We don't want it too slow because, let's say for instance, a storm rolls in and the amount of daylight coming in through the window really decreases rapidly. We don't want that deadband plus the ramp rate to make it take too long to be able to boost the light in the space. But we we also don't want it to be so quick that people are like, what's going on with the lights? So there is an art to how you're balancing your deadband and your ramp rates. But there's also time delays, which is more about having unexpected changes happen. So a cloud passes by, or somebody walks in front of the sensor, or somebody shines a flashlight into the sensor, or car's high beams pass by. All of these events could cause the lights to, or the sensor to react. So giving it a bit of a time delay also helps prevent it from having a false trigger. So, you might have a time delay of 30 seconds, and that 30 seconds, it basically goes, okay, I see that there's a change. We're going to wait 30 seconds and see if that change stays or goes away. And if it goes away within those 30 seconds, nothing happens. But if it stays, then we're going to go into our deadband, then we're going to go into our ramp rate, and eventually that change will happen. But all of these variables are really important to keep in mind when it comes to daylight control, because what we're trying to do is respond in a way that's comfortable and provides the visible illumination that people need for the space without either wasting energy or making it too bright or too dark. So hopefully you've learned something about daylight responsive controls. We didn't drill too deep into it, but this is sort of the basics of how daylight responsive controls work. There's a whole lot of great information out there that we have on the Lighting Controls Academy's website, or if you want to take the full course at NEMA Academy, highly recommend you check that out. But ultimately, what we are talking about here is how we are zoning, how we are controlling, and the different considerations that you want to keep in mind when you're creating a daylight responsive system, especially if you're trying to reduce energy waste, which is a very good reason to use daylight responsive controls. But additionally, just thinking through, okay, how am I zoning? Which sensors am I using? Am I using a way to tune into the brightness, and how long am I going to dial into that? And then as final steps, it's really important to make sure that you test, calibrate, and adjust for the real occupant use, not just for the artificial occupant use. In a design documentation format, in the model, in Revit, it's very easy to go, yeah, this is probably what's going to happen, but having the real world test, making sure that the system is behaving as it was specified, is really the most important thing. So you may need to come back. It may be expected that the technician comes back and recalibrates things because the predicted behavior isn't actually standing up to what the real behavior should be. So anticipate a little bit of fussiness with the programming and calibration, but at the end of the day, when daylighting controls are well done, you don't notice them because they're just so effective that they are responding in real time to the changes that are happening in a way that is comfortable and supporting the task that you're trying to achieve. Thank you for joining me. I'm Webster Marsh, the Education Manager for Lighting Controls Academy. Hopefully you enjoyed this video, and you should check out all the other videos that we're coming out with. Thank you, and hopefully I'll see you in the next one. Before you go, a quick word about who we are. For over 25 years, the Lighting Controls Academy has served as the voice of the lighting controls industry. As a coalition of the National Electrical Manufacturers Association, or NEMA, we were created to help educate the public on lighting controls technology and real-world applications. Our hallmark program is our online education, including this video series, along with written courses through NEMA Academy. If you want to keep learning about lighting controls, head to lightingcontrolsacademy.org. You'll find articles, industry news, new products, award-winning projects featuring controls, and plenty of other helpful resources. Thanks so much for watching, and hopefully we'll see you in the next one.